Okay, guys, we're gonna start by going over the homework. We are on page 23. You only had to do the bottom because obviously we had the notes up here. Read all the words, always really important. So it starts off with the diagram below shows gradual stages 1, 2, and 3 in the development of a river delta where a river enters the ocean. So you look at the pictures because reading all the words means looking at the pictures. You see here in stage 1, we have a river that enters into an ocean. An ocean. Here we have that same river in stage 2, but you can see some things are getting left behind and dropped off. Stage 3 still have that river, but you'll notice a lot of stuff has been dropped off. Which statement best explains why the river delta is developing at this site? Give me a show of fingers so I can kind of see if everybody's got the general gist. Heck yeah, it looks like everybody's got that one right. The rate of deposition is greater than the rate of erosion. That means more stuff's getting dropped off than is getting carried away. Perfect. Question 2. Question 2 goes back to what we talked about yesterday a little bit. It says an environmental scientist needs to prepare a report on the potential effects that a proposed surface mine in New York State will have on the watershed where the mine will be located. In which reference material would the scientists find the most useful data which determine the watershed's boundaries? I'm going to use this as a teachable moment to remind you, and I think I didn't do a great job of talking about this yesterday. And I think it goes along with some of the questions you guys are asking. So here we looked at this picture yesterday, didn't we? Did we look at this one? Yeah. This is the Mississippi River's watershed. So if you remember what a watershed is, it's all the land that drains into the Mississippi River. Jake, I need you to put your phone away. If I have to ask you again, I'm going to take it. So the Mississippi watershed is all the water that drains into the Mississippi River. So if a drop of water lands anywhere in this dashed area, it will eventually, not necessarily tomorrow, but eventually make it to the Mississippi River and flow out the Gulf of Mexico. But what I did not talk about yesterday was, well, like what, like, are these just like imaginary dots? Like, how did they decide that here the water's going to go this way towards the Mississippi and here it's going to go over towards the Colorado? What do you got to say? Yeah, but we're not talking about the question anymore. I moved up here. So what I want to ask you before we get back to the question is, what is along the edge here that is kind of saying if water falls here, it's this way, it's going over here, and this way is over here. Do you guys know where this dotted line is? Or what landmark is over there? The mountains, the Colorado mountains. So basically, there's a whole mountain range. So similar to what I was talking about with Klutz Boys and Tim Hortons, that they're on tops of hills and they go down. If a water droplet falls right here, it's going this way towards the Mississippi. But if it lands on the other side of the mountain, it's going this way. So it's like there's a border of mountains on this side. Well, what's on this side then? Another set of mountains. This is the Appalachian Mountains. And the same deal happens here. So it's like you got walls of a mountain on either side of a bucket that drains into the Mississippi River. So the watersheds are determined and controlled by the mountains and the hills. Now back to the question. Like Brennan said, it says, so what should we look at to decide where these boundaries are? So the boundaries were mountains. So, and again, Brennan already answered this one. It's topographic maps. Do you guys remember what a topographic map was? Yeah, it's those maps, if you remember to connect the dots for slightly older kids, they showed elevation. So topographic map's going to show us where the mountains are, where the hills are, and which way they're kind of aiming. So we would look at a topographic map to decide where the edges of a boundary or the edges of a watershed are. All right. So, and then here we got that same exact map on the back here. Base your answers to 3 through 5 on the map below, which shows the drainage basin of the Mississippi River. Several rivers flow into the Mississippi River are labeled. The arrow at X shows where the Mississippi River enters the Gulf of Mexico, so right there. The entire land area drained by the Mississippi River system is referred to as, what is all this land that drains into the Mississippi River? What's that called? It is a drainage basin, but that's not an answer. There's two words that we learned yesterday that basically mean the same thing: drainage basin and watershed. So just grab the notes that you missed yesterday and you'll have that one just fine. Now, sediments deposited at X, so right here where the river enters the ocean, are most likely which characteristic? Are sediments that get deposited by a river, are they going to be angular? No, in fact, what will sediments deposited by a river be? What shape?
Round.
They're going to be typically round. Remember, they get round by rolling in the river. Are they going to be rock particles that are arranged in sorted beds? Do rivers sort the sediments when they enter a lake? Ooh, do they or don't they?
No.
No? Rivers, just dump them off? Water slides, just dump people off? Doesn't matter their size, shape, or density? No? Yeah, but remember, this is page 14. Oh, there we go. When a river or stream enters a lake, or when the water slide enters the pool, do you remember where is a big adult gonna land? Right at the bottom. Where are my teeny tiny kids gonna land? No, they don't land on the top. They're gonna go out further. And so as a stream slows down, just like when wind slows down, it drops off the biggest sediments first, then the medium sized, then the tiniest particles. So water does sort them, and it sorts them according to their size, shape, and density. So when you get to where a river enters an ocean, these are going to have sediments deposited in sorted beds. They will be organized based on their size. All right, the structure formed by the deposition of sediments at X is best described as, is that a moraine, a delta, a tributary, or a drumlet? Right here at X. Yeah, that's a delta. A delta is formed where a river enters a larger body of water. I have a question. What makes moraines? This is quick review because if you didn't notice, we're gonna have a test next week. What makes a moraine? What agent of erosion? There's 5 of them. So hang on, here's what, nobody shout out since nobody, it seems like they can remember. We've done wind, glaciers, gravity, and running water. Flip through your notes till you find those. And see what makes a moraine. Is it a glacier? Is it gravity? Or is it running water or wind? Everybody should be looking back through their notes. Find where we took notes on gravity. So that was pages 8 and 9. Find, that's where we got gravity, wind, and glaciers. Which one makes a moraine? Moraines are made by glaciers. That should be on the glacier box. So everybody flip to your glacier box. So that's either on page 8 or 9. Do you have moraine listed there? So that is something that you're going to need to know off the top of your head for next week. I have the test tentatively scheduled for Tuesday. There's a possibility it gets pushed back. We'll have to wait and see. But that's what you need to be able to do. If I say moraine, you need to think glaciers. If I say delta, you need to think running water. If I say, what about drumlin? What makes a drumlin? Same thing, guys. Go to pages 8 and 9. See which one makes a drumlin. This is also glaciers. That's the type of stuff you need to just go drumlin, glacier, U-shaped valley, glacier, V-shaped valley, river, delta, river. We'll review this and we'll make a review sheet for the test, but you got to start thinking about this now because the test is coming up. All right, question 6 is a throwback to chapter 3. It says most of New York State's sandstone bedrock. Sandstone should sound familiar. It's a rock. Who remembers what type? Is it igneous, sedimentary, or metamorphic? Sandstone is a sedimentary rock. So it's really asking, how is the sedimentary rock sandstone formed? Read through each answer. Which one forms a sedimentary rock? Which one is it, guys? It is when sand grains get deposited, buried, cemented together. That was last night's homework. How'd you do? Okay. Keep in mind that they would be worth a little less than 20 points each. Get one wrong, you have like a 77. Or no, you would have like an 84. Sorry, went the wrong way. All right, so we're going to move on to I stream, U stream. And I know I kind of got this started yesterday. So I think we did the reading, didn't we? All right. So you need the river in front of you. So if you haven't already come up here and got the Ritz River, you're going to need the Ritz River in front of you. So the Ritz River, which flows into MRD Lake. Yep, you got me. I was trying to be funny. I feel like I did. That's funny. All right. So this is the river. And according to the paper on page 25, the I stream, U stream, I already told you the elevation at some of the locations. So at location A, according to the paper, the elevation at A is 500 meters. Why don't we go ahead and write that in? The elevation at B is 427 meters. And again, I'm getting this right from page 25. C says it's 378. 218 and 106. So that was right off the paper. So these are elevations, which means how high they are. So are they really high on the mountain? Like A, that's 500 meters up the mountain. E is down at 106 meters. So that's how their elevation. Then we're going to use the scale to see how far apart they are. So how many kilometers away from each other they are. So what we have to do is we're going to be calculating gradient. Guys, what's another word for gradient? Slope. So if you don't remember that, you might want to put it up here. Slope. What did we talk about with slope? The steeper the slope, what do we know about the river? The steeper the slope, the faster the river, and when we have more speed, what do we know about erosion? More erosion. Faster the stream, the steeper the stream, the faster the stream, the more erosion we'll have. So we're going to be going back, just like we did, and we went back to chapter 3. Well, we're going to do a throwback to chapter 2 and talk about gradient. Gradient is a fancy word for slope, and we learned how to calculate gradient. Do you guys remember doing this? What? We need a formula. Oh, did we do this already? Oh, good, good. Change in field value divided by distance. And where do you find that? Just, yep, front page of your reference table. Change, I remember now, field value divided by distance. Oh, I shouldn't be writing a marker because, oh well, too late. Now remember, field value is just whatever is being measured. So if I was measuring temperature, it's a change in temperature. If I was measuring pressure, it's a change in temperature. But on this map, I'm measuring elevation. So we're going to be just doing the change in elevation divided by the distance. So I gave you one I wanted to do right here. We need to calculate the gradient between B and D. So we have point B and you have point D. So can we do the change in field value? How do we figure out if we know B is 220 or 427 meters and D is 218 meters? How do I find the change? Perfect. So gradient is the change. So I got to subtract. So B is 427 meters and D is 218 meters. So I got to subtract those. So grab a calculator and go right ahead and subtract those. You can use your phone to subtract, not to text your mom happy birthday. All right, it's fine with me. Even though I saw his eyeballs. What do you get? 209 meters. So those two locations are 209 meters of difference in elevation. That's how much it changes. So B is way up here. D is way down here. So that's their change in elevation. Now we need to figure out their distances. So in other words, how far apart they are. How will we do that? We're going to use the scale. Now you guys have done this. One thing we talked about earlier in the year is I don't like when you use a pencil and you kind of hold it. I don't like when you put your finger there and you try to figure out how far apart they are. I want you to use a scrap sheet of paper. You can use the edge of your packet. That's fine with me. But here's a dilemma. Here's B, here's D. We got to go around the curve. You can't just measure straight from B to D because you're skipping a whole bunch of the river then. So we have to go around the curve and you have to do this with, you only have a straight sheet of paper. How do you think we're going to do this? Yeah, you kind of got to follow the river. So does everybody have a piece of paper you're going to use as scrap? Again, you can just use the edge of your packet. Line up your page and mark off where B is. And then like Justin said, we're going to go over to C first. So here's C. I'm just going to mark a little label on that just to make my life easier. Now, how do I get from C to D? What do I got to do? Yeah, you kind of got to move the paper. And it's not going to be perfect, but it's the best we can do with what we got. Now I want to compare that just you guys don't have to do this, but you can see it's a significant difference. If I had just gone straight across the paper, D would have just been here. So it is a good little chunk difference. And that's important. I have seen this come up on the Regents one year. They had a map from Pennsylvania state line on the thruway over to Syracuse. And if anybody knows how that looks, the thruway goes north a little bit and then straight west. And they wanted the distance you were traveling and you couldn't just go on an angle. You had to follow the road up and then over. So anyway, now that you have that marked, you put that down on the scale. About how long is it from B to D? No, from B to D, not from C to D or B to C. Yeah, I'd say about 7. I'm a little before the 7, but we'll go with 7. Did you guys get that ish? And if you wanted to call it probably it would be better for me to call it 6.9 or 6.8, but for today, we're going to go with 7. Andy wanted to be a painter. Such a waste of, oh, okay, good to know. All right, so that's 7 kilometers is the distance between them. Go ahead and plug that into your calculator. 209 meters divided by 7 kilometers. What do you get? $29.8. What'd you say? 9-7 or 5-7. Thank you. By the way, in science, they're usually going to tell you to round to the nearest tenth. How would that number 29.857 be rounded to? 29.9. 29.9. What are the proper units? Not. They're right there. Meters over kilometers, which means meters per kilometer, which means as you go down the road or down the river in this case, every kilometer you go, it's going to change elevation of 29.9 meters every kilometer. All right, can you do the same thing from A to E? Okay, that wasn't a question. Do the same thing from A to E. I'll let you guys try that one on your own. Yeah, these ones are going to be pretty far apart. So remember, when you're measuring how far apart they are, you got to follow the curve. So it's actually a really big difference now. What do you need?
Can I use my phone?
Yes.
Yeah. Okay. What you get? 35.
We take some melatonin before school. I'm just gonna call
So we're good now. 39 now. So we're going to be 39.
Is that your distances? Yeah.
Oh, no, it's how far apart are they?
So this is from A to B. Okay, and then
Are you?
just A. Those ones are fun.
So 38.
I'm a philosopher. Why? I did the wrong one.
Okay, hold it.
How far apart are they? All right, guys, how far apart were these two A and E? No, that's not what I asked. That's not what I asked. I asked how far apart they were. That's not what I asked. So to do this, you did have to go all the way around. There's A to B, there's B to C. Yep. There's D, and then there's E. You can see this time it's quite significant how far away that would have been if you went a straight line. You would have really been too long, or I'm sorry, too short if you went just the straight line. But then you came into the dilemma where this mark was bigger than the scale. Guys, if this ever happens, remember, you can start over. So there's A, and there's where it hits the 8. So now what you do is you start over. I see how I made a little mark for the 8. If I start over and put the 8 on 0, now instead of this being 0, that's 8. This line will be 9, 10, and mine came perfectly out at 11. If you went with 10.5 or 11 point something, that works too. But you're right, Jake, I probably should have started with the top number. How do we figure out the change in field value? Subtract them. 500 minus 106, and that's going to be divided by 11. What'd you get for your top number? 3 something, right? 394 divided by 11. Who has these exact numbers that can give me an answer? Okay, meters per kilometer. So that part, the whole river is steeper than that first section, right? Are these the numbers? Does everybody agree with Riley and Jake? Yep. I agree. All right, now the next thing is we got to talk about channel shape, because we know that on straightaways and curves, the river is going to be moving at different speeds. And there is a concept that we need to get here. So let's start here. It says channel shape. The position of maximum velocity in a stream cross-section varies with changes in the direction of the stream flow. The velocity of a stream is generally greatest just beneath the surface, near the center of a channel, where there is less friction with the banks of the river and the atmosphere. Water near the outside has a greater velocity than water near the inside of a curve. Therefore, erosion takes place on the outside of a curve, and sorry, I just got lost. Therefore, erosion takes place at the outside of a curve and deposition on the inside. What we need to do is on these cross sections, we got to draw what the riverbank or what the floor of the river looks like. Basically, what I'm asking you to do is if you hopped in the water at A and started to wade across the river, what would the bottom of the river look like? Like what shape would it be? And well, actually, it would be more of a V, but that's besides the point. But you're right, it has that general U-ish or V-ish shape. But depending on where you are in the river, the deepest spot is going to be in different places. And that's because of one concept that I think is important to know. And we have some room at the top here to write this. Guys, where's the water moving the fastest on a stream's curve? On a stream's curve. Where, so the inside or the outside? The outside. So the water's faster here. When the water's moving faster, what happens in terms of erosion? More erosion. The faster the water, the more erosion. And if we have more erosion, is it going to, how deep is it going to be where there's more erosion compared to somewhere where there's less erosion? It's going to be deeper. Perfect. So wherever the water's moving the fastest, that's where there's the most erosion. And then wherever there's more erosion, it's always going to be deeper there. So here's what we need to do. We're going to be drawing what these river bottoms look like. So as we go from A to A prime, now what I want to make sure you understand here is in this box, don't pack up, anyone who's packing up, the top of the water's up here. So the water's up here. So you are going to be standing up here and jumping in the water, and I want you to draw what the river's bottom looks like. So let's look at A, walking over to A prime. Take a look at this. Ask yourself first, is this a straightaway or is this a curve? This is a curve. And is A the inside or the outside of the curve? This is the inside. And this is the outside. So where is the stream moving the fastest? The outside at A prime. So since A prime's moving the fastest, that side's going to be deeper. So on your note, on this packet here, you find A prime. And what I want you to do is put a dot where the deep section is going to be. It's over near A prime. So if you label where the deepest spot is first, then what you do is you go ahead and you connect where you were standing to the deepest spot. And then when you get to the deepest spot, you're going to draw what it would look like to walk up that other bank. So this is a little exaggerated. So no, it's not going to be quite this steep in real life and quite this gentle, but the key is that the deepest section is going to be off towards the outside of the curve. Not done yet. Let's do B to B prime. Again, ask yourself, is this a straightaway or a curve now? B to B prime, is that going to be? That's a straightaway. It's not on a curve. So where's the deepest spot going to be on a straightaway? In the no, it's not all deep. There's always going to be a deepest spot. And I heard a bunch of you say it's right going to be in the dead smack center. So find the dead smack center and put the dot there. Connect these. And what you'll get is the sides are basically equal. So you guys, we are a teeny tiny bit behind. I would like you to finish these other three for homework. So you'll have to take home your Ritz River. But I'm just asking you to do C to C prime, B to D prime, and E to E prime. I'll put that up here.